Hello everyone. In this video I will explain the method for calculating circular convolution of two sequences. The method that we are going to discuss is the concentric circle method. And imagine that you are given with two sequences x1 of n and x2 of n, and both of them must have the same length, capital N. Otherwise append necessary zeros to the shorter sequence to make both of them of the same length. Then as the first step, graph the samples of x1 of n at equally spaced points around an outer circle in the counterclockwise direction. Then the second step is start at the same point as x1 of n, then graph n samples of x2 of n at equally spaced points around an inner circle in the clockwise direction. Then next step is multiply the corresponding samples of two circles and sum the product to produce the output. Then to get the next output, rotate the inner circle one sample at a time in the counterclockwise direction. Then go to step number 3, that is multiply the corresponding samples of both the circles to get the output. Then we have to repeat the rotating process and multiplication until inner circle's first sample lines up with the first sample of the outer circle once again. That is, what was the position of the two circles in the first step. Whenever we reach at the same stage again, we can stop the procedure. Okay, so I will demonstrate this particular method by using an example. So imagine that I have a sequence x1 of n, and the sequence values are 1, -1, -2, 3, -1, and x2 of n, or the second sequence is hello. ഓക്കെ 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 അങ്ങനെയാണെങ്കിൽ ഞാൻ അടുത്ത ആഴ്ച വരാം. കാരണം ഇനിയിപ്പോൾ നാളെ ക്ലാസ് ഇല്ലല്ലോ, നാളെ അവധിയല്ലേ. നാളെ മറ്റേ ഇതല്ലേ, ശ്രീകൃഷ്ണ ജയന്തി അങ്ങനെ എന്തോ അല്ലേ. ഫ്രൈഡേ നമുക്ക് വർക്കിംഗ് ആവുള്ളൂ. അതാവും നല്ല. അതെ, വെള്ളിയാഴ്ച വർക്കിംഗ് ആണ്. വെള്ളിയാഴ്ച എനിക്ക് തോന്നുന്നു കുറച്ച് സ്റ്റാഫൊക്കെ, നമ്മളെ സ്റ്റാഫൊക്കെ വരുന്നുണ്ടാവും, ടീച്ചിങ് സ്റ്റാഫ്. ശരി എന്നാൽ ഇതില്ലോ, താങ്ക്സ്. ശരി. And the second sequence x2 of n is 1, 2, 3. Okay, so when you look at the first sequence, you can see that the number of samples of the first sequence is 5, the number of samples of the second sequence is 3. So we have to make both of them of the same length, so we need to append 2 more zeros to the second sequence, then it will have a length of 5. So I'm rewriting the value of x2 of n as 1, 2, 3, then 0, 0. Okay, so this is the peculiarity of the circular convolution. Both of them should have the same length and our output will be of the same length. Okay, so here I can write the common length of the signals as n equal to 5. Okay, now we are getting into the procedure of the concentric circle method. So we have to have a inner circle as well as the outer circle. So I'm drawing an inner circle and an outer circle. So this is the outer circle, and I'm drawing one more circle, that is the inner circle. And I'm drawing one more circle, that is the inner circle. Okay, now what I have to do is I have to graph the points of the two sequences around the circle. So in the first sequence I have 5 points, also in the second sequence I have 5 points. So I'm starting at this position, then I am marking the values of the first sequence over here. So I'm writing the first sequence 1, and we have to write it in the counterclockwise direction or in this direction. So the first sample is 1 and the second sample is -1. The third sample is -2. The fourth sample is 3 and the fifth sample is again -1. Okay. Now we have to draw the points around the inner circle, that is the sequence values of x2. So I need to start from the same point. So I'm starting from this point. So the first value is 1 and the second value is 2. So I need to draw it in the counterclockwise direction or in this direction. Okay. So I'm drawing that value over here to align with this -1. So that is the value 2. Then I have the next one, that is 3. Then the next value is 0 and another value is again 0. Okay. Now in order to get the first output of the circular convolution, I'm writing it as y of 0. So that y of 0 value will be the sum of the products of these numbers. Okay. So I need to multiply 1 and 1, so it will be 1. Then 1 -1 and 0, so that will be 0. Again -2 and 0, again 0. Then 3 into 3, that is 9. Then this is 2 into -1, that is -2. Okay. So if you do the math, then this would be 8. Okay. Now in order to get the second sequence, I need to rotate the values of inner circles in the counterclockwise direction, that is in this direction, by one sample at a time. Okay. So I'm making a copy of this one. Now I need to rotate the values of the inner circle one point at a time. So I am removing the values that is already written over here. And when you rotate the values in the counterclockwise direction, this 1 would become at this position, this 0 would be at this position, this 0 would be at 3, and this 3 will go to position of 2 and 2 will go to the position of 1. So this would be 2 1 0 0 3. Okay. Now we have to multiply the values together to get the next output. So we are finding y of 1. Y of 1 would be 1 into 2, which is 2. Then -1 into 1, which is -1. 2 into 0 will be 0. Sorry, -2 into 0 will be 0. 3 into 0 would be again 0. Then 3 into -1 would be -3. So this value would be 2 minus 1 would be no, 2 minus 1 would be 1. So 1 minus 3 would be -2. So to get the next value, I'm doing the procedure again. So I'm just taking a copy of this one. Then I need to change the values of the inner circle by rotating it to the counterclockwise direction by one sample. Okay. So I need to rotate these numbers, so this 2 will become at this position and that will apply for all other samples. Okay, so I will have 2 over here, 1 here, 0 0 and 3. Okay, now we are multiplying the values together, so I'm writing y of 2 equal to 3 into 1 is 3, -1 into 2 is -2, -2 into 1 is -2, 3 into 0 is 0, -1 into 0 is 0. So this would be 0 plus 0. So this is actually 3 minus 4, which is -1. Okay. Now as the next step, I need to take a copy of this one. Okay. Then we have to rotate the points in the inner circle. So I'm rotating this one. So 3 would be over here. Then 2 at this position, 1 over here, 0 and 0. Then we are multiplying the values together to get y of 3. So y of 3 would be 1 into 0 0, minus 1 into 3 minus 3, minus 2 into 2 minus 4, 3 into 1 is 3, 0 into minus 1 is 0. So this value would be minus 3 and minus 3 are cancelled off, then you will have minus 4. Okay, then you will have one more sample to obtain, because the output will have 5 samples. We already obtained 4 samples. So as the next step, I am deleting the values of the inner circle. Now I will have these values rotated. So here I will have 0, then I will have 0 here, then 3, then 2, then 1. Now we are going to obtain y of 4. Y of 4 is 0 into 1 is 0, minus 1 into 0 is 0, 3 into minus 2 is minus 6, 3 into 2 is plus 6, 1 into minus 1 is minus 1. So this would be 6 and 6 can be cancelled, would be minus 1. So we have obtained all the samples of the output, and if you rotate the last inner circle once again to the in the counterclockwise direction, that would be exactly similar to the position that we saw in the first sample. Okay, so the values are 8, minus 2, minus 1, minus 4, and minus 1. Okay, so the output signal y of n is 8, then minus 2, minus 1, minus 4, minus 1. Okay, so this is how you find the circular convolution of two sequences using concentric circle method.